quiet, please. We're going to go ahead. Oh, are we doing notes now? Yeah, you're doing notes now. So the first thing, okay, Connor, turn around. The first thing I want to show you is, I mean, how many of you are feeling pretty comfortable about using the calculator to solve a system?
I am.
Better than the others, right? Better than the others. But here's the thing about, if you know how to solve a system by graphing, or like we just learned, that actually that can help you if you go back to just like chapter 3 stuff where we had to solve equations. So let's say this is your equation to solve. What you can do is enter the left-hand side on the first line of y equals, enter the right-hand side on the second line, unsimplified, just like it is, and then do second trace 5, enter, enter, enter. Right? Wherever they intersect, that's the solution. The x value is the solution. Like, try this with your calculator. I mean, this can work for every kind of equation, even like complicated trigonometry and logarithms or whatever. This method always works. So clear. So watch this. Y equals 3x minus 4. Yeah. Okay. Clear the memory. Second plus 712. So you should have, again, you should have this on the first two lines, just like I've got it right there, right? The left-hand side equals the right-hand side. And now, if I look at the graph, there's one line, there's another line. Okay, quiet, please. Do you see the intersection point?
Yep.
Okay, so what if you didn't see the intersection point? Zoom out. No, zoom 3. Zoom 3 zooms out. Zoom 6 brings you back to normal, right? So since the intersection point is there, then do second trace 5, enter, enter, enter. And, you know, it's going to intersect at a point, but you don't care about the y value, right? There was no y in this equation. We introduced the y to solve it as a system. So all you care about is x equals 2. There's your answer. So it doesn't matter how complicated the equation, you can solve it this way. Just to let you know. Okay, so this is like one more of the solving systems, but it's actually more addressing. Okay, what is it? What about if it doesn't just have like an intersection point of the graph? What does that look like when you're solving? So let's say I have to solve this system algebraically. Okay. Do you think substitution or elimination would be easiest on this one? Elimination. I mean, it's in standard form. The variables are lined up. So let's do substitution or elimination. But they're not ready. If I add right now, it's not going to cancel anything. What should I do before I try to add? Multiply the top by 2, right? So if I multiply this one, by 2, right? I get my equivalent system, which is 6x plus 4y equals 20. And then the second equation is unchanged. And am I ready to add them up? Yeah. It's just what happens when I add them up this time. Yeah, the x's cancel and the y's cancel, and I get 16. So I get 0 equals 16. What's wrong with that? It's not true. So what does that tell you about the system that we've got? There's no solution, right? Just like when we were solving equations, if you get down to something, a statement which has no variables in it, and it's false, that means no solution. Right. So what does the system look like that has no solution? Which one of those has no solution? The parallel lines. So it must have been that we were given parallel lines, and that's why there's no solution. Yeah. If you solve those for y and put them in the calculator, you would have had, you know, two parallel lines. But then if you tried to do if you did that, right, and so on your screen you've got two parallel lines, and the first question I'm always asking you is, do you see the intersection point? And you say, no, there is none. And guess what? You could zoom out and zoom out and zoom out. It's never going to be an intersection point. So you really, if you try the method, second trace 5, it's going to always error. So when you have parallel lines, what's true is they have the same slope. Right? They got to have the same slope, but they have different y-intercepts, right? Different y-intercepts. That's why they keep going up and over exactly the same. They weren't touching at the beginning. They're not going to touch every time you go up and over. Still not going to touch. Okay, how about this one? Would you think we should solve a substitution or elimination?
Substitution.
And why is that again?
It's already solved, so why would
Yeah, one of them is already solved for a variable. So let's do by substitution. So what would I do next? Plug in what y equals here. So x minus 2. Okay, then parentheses 1/2 x plus 2 equals -4. All right, now simplify. X, what's -2 times 1/2? So minus x, -2 times 2. Minus 4 equals -4. So these two cancel, right? Combined like terms cancel. And you get -4 equals -4. Is the -4 not equal to -4?
It is.
That's reflexive property, right? Something equals itself. Absolutely true. But there's no variables involved. So it doesn't depend on x and y. It must always be true. So which one of our systems is always, yeah, they're right on top of it. Actually, those are two different equations for the same line. So actually, they share infinitely many points. So every value of x, every value of y is in there somewhere. Okay, when does that happen? Well, obviously, they have the same slope and the same y-intercept. That's why it's the same line. So try to solve that system. It's going to be one or the other. So your answer is going to be either no solution or infinitely many solutions. Which one is it?
No solution.
Because is this thing, do you have to multiply by anything?
No.
No, I mean, it's already set up to add. So what do you get when you add these? 0 equals 9, which is a false statement, no solution. So what kind of lines are these two? Parallel, right? When you get a false statement, that means the lines must have been parallel. So 0 equals 9. False. That's not the way you spell false. False. No solution. Parallel lines. All right. Last slide. Do the same thing there. Looks like this one might be a substitution. Although you could. So if I substitute, right, -6x plus 3 times 2x minus 4 equals -12. -6x plus 6x minus 12 equals -12. Right? These cancel. Right? So -12 equals -12. So this is the same line. which doesn't mean that there's no solution, but there's no unique solution, right? Unique solution means it's one point. This means there's infinitely many. And that was the very short lesson that we had for today.